So let us write down the objectives. Last time we introduced exponential model. So we're going to continue exponential model. And now we're going to try to see the behavior of different data. So you get different functions and understand the pattern. And eventually we're going to use those information to make predictions. Perfect. So recall that. Last time we said that, hey, sometimes a linear model doesn't work very well. Sometimes we need a new model to actually just use a mathematical model to understand the pattern and behavior in our data. So sometimes we need a new model to understand the pattern in our data, and it might be an exponential model. Remember last time we talked about the amount of radiation level. We say y hat is equal to A, the initial amount, times B to the x. A, the initial amount, initial value, and B, we call that either a growth or a decay factor. So if B is greater than 1, it means that we have a growth factor. If B is in between 0 and 1, we have a decay factor. Decay factor. Last time we saw a model with decay factor. Again, recall our radiation. After explosion, we had some radiation. Recall our radiation example. The exponential model that we had was the following. Y hat was equal to 2000.95 to the x. And remember that, remember the pattern that we saw, the pattern was like this. X was the number of years, and the amount of radiation was a decreasing graph. Why is that? The initial amount is just 2000. That makes sense, 2000. This is your A. Your B, 0.95. This is just a decimal number. B is 0.95. A decimal number which is in between 0 and 1. So 0.95 is in between 0 and 1. It means that we expect to see a decreasing pattern, a decay pattern in our data. So you say, since B is 0.95 less than 1, it means that we have a decay in our pattern. What's the meaning of that? It means that as x increases, your predicted y value is decreasing. In other words, as x, independent variable, response was dependent, and here you have independent variable. independent or explanatory. Then you had response or dependent, so X or independent or explanatory variable. Increase, then our Y, or Y hat in this case, the predicted amount, dependent. Another name for dependent, response variable decreases. Okay, guys, please take your time, write this down. If you have any question, today we're going to talk about an increasing model. We're going to see a growth in our pattern. Today, we want to investigate an increase in our model. Let's take a look at one example. So in previous lesson, we talked about the amount of radiation. Then we also talk about European rapid population in Australia. And you saw you have an increasing pattern. We also talked about decreasing pattern or exponential decay. Today, we're going to talk about exponential growth. Our example is Facebook membership. The online social networking site Facebook was launched in February of 2004. So this is the beginning year, 2004. From 2004 to 2010, Facebook membership grew rapidly as its popularity increased. Facebook tracks its number of users closely and uses this data to generate new business opportunities. The table and graph below provide information about Facebook membership measured by number of Facebook users for selected months between December 2004 and July 2010. The membership counts represent the number of people who are Facebook users. I know many of you don't use Facebook anymore. The numbers are given in millions, so 5.5 means 5,500,000 users or accounts. Let's take a look at the pattern in our collection. So here you have month and year, December 2004. Months since February 2004, you get 10 months. So February 2004, December 2004, we have 10 months. So Facebook actual membership, millions of users, 1 million users. Well, let us move on to next year, December 2005. How many months? 22 months. So these are your X values. How many members? 5.5 million users. So from 1 million, it increased to 5.5. Then in December 2006, 34 years since February 2004, we get 12 million users. Then in April 2007, 38 months since February 2004, we get 20 million users. And as you can see, this number increases. So the information that we have, the last part is for July 2010. 77 months after February 2004. And as you can see, you have 500 million users. Let us take a look at our scatter plot. On horizontal axis, you have the number of months, 10 months, 22 months, 34 months, 38 months, 44, 54, and so on. And on the vertical axis, we have our dependent or response variable, which is the number of users in millions. As you can see, it's not a linear pattern. The pattern that you see here is exponential. Facebook membership can be modeled by exponential curve y hat equals to 0.8 times 1.09 to the x. In this equation, y hat is the predicted number of Facebook users in million and x is the number of months since Facebook was launched in February 2004. Let's take a look at the formula on the board. So y hat is equal to, in our example, Facebook users. Y hat, the predicted number of users, is given by this model 0.8 times 1.09 to the x. Okay, let's try to analyze this, what's going on. 0.8 is the initial amount. This is your A, initial numbers of users. 1.09 is actually your B. B is equal to 1.09. As you can see, B is greater than 1. Since B is greater than 1, larger than 1, it means that we expect to have an increase in our pattern. So you can write since B is greater than 1, so we have a growth factor. It means that we expect to see an increase in our model, which is true. We just saw the model. Try this. According to the exponential model, when did Facebook's predicted membership exceeds growth larger than 200 million users? And two, what did the value 0.8 and 1.09 in the exponential model mean? In your explanation, think about exponential curve. Well, 200 million users. 200 million users is actually related to April 2009, 62 months after Facebook launched in February 2004. So it's going to be April 2009. After that, you see the number of users, it gets larger and larger, 250 million, 300 million, and so on. You can take a look at your graph as well. So 200 is 200 million users is associated to the year here. Sorry, the months here. So on our horizontal axis, we have the months. We can take a look at our table to actually get the year. Question 3, 4, and 5. Use the exponential model to predict Facebook's membership in September 2007. How many months? 43 months after its launch, and in January 2010, 71 months after it's launched, and round to the nearest million users. 4. Use the exponential model to predict Facebook membership in March 2011, 85 months after Facebook website was launched. And 5, consider the predictions you just made in your answer for question 3 and question 4. Which do you think is more reliable? Give a reason for your answer. Think about the data that were used to create the model. And 6, membership data was not reported until 8 months after Facebook's launch. Use the exponential model to predict how many users Facebook had when it started in February 2004, which is 0 months. Do you think this answer is realistic? Why or why not? So for question 3, the information that we have, let me just clear some part of the board for you. Of course, you have to use your calculator. For question 3, it says, what is the y hat? What is your y hat if x is equal to 43 months? What is your y hat if x is equal to 71 months? And for question 4, it says, what is your y hat if x is 85? How many users Facebook had after 43 months, after 71 months, after 85 months? How many users Facebook had after 43 months? So we have a nice formula. Our goal is to use that formula. We have y hat equals to 0.8 times 1.09, and your x is equal to 43. So substitute that here. 40. What is your y hat? For x equals to 71, your y hat is equal to 0.8, 1.09 raised to 71. So one by one, we have to substitute these new x values, calculate the number of users. 71. And here you have x equals to 85. We're using the nice formula that is given to us, this exponential model. And here we have y hat equals to 0.8, 1.09 raised to this new x value, which is 85. 85. Okay, take your time, calculate this. By using our calculator, the first one is going to be, so y hat, how many users Facebook had after 43 months. After 43 months, it's going to be about 33 million. So for about, we can use about instead of using equality, use this symbol to show that we just approximate that 33 million users. If we plug in 71 for our x, the exponent is changing, we get about 363 million. So about 363 million. And after 85 months, excellent, Anna, you get 1,214 million. So 1.2 billion users. So how about the initial value? How do you find the initial value, and does it make sense? So at the beginning, it means that it just started. At the beginning, it means that x is equal to 0. When x is equal to 0, your predicted number of users, Facebook users, is 0.81.09 raised to x. What is x? X is equal to 0. So let me use this color here, a different color, so you know I just plug in 0 for my x. Very well. So you have a non-negative number raised to 0. This is equal to 1. So y hat is equal to 0.8 times 1, which is 0.8. It says you had 0.8 million users. At the beginning time that Facebook first started. It was public to everyone, it was launched. Does it make sense to you that Facebook had 800,000 users when it was first launched? Is it realistic? I don't think so. So as a statistician, you're also interested in the percent of increase or percent of decrease. So suppose you have the initial amount, the number of, for example, Facebook users as just the initial amount. And then it increased or it decreased. Remember that. When we're talking about increase, you can think about the number of Facebook users. When it decreased, you can think about the amount of radiation after the explosion. So you have initial amount, for example, at the beginning, or you can think about this as you look at the data during any months, any years. Then after the initial amount, you have some new amount, all right? New amount. For example, the amount of radiation after, for example, 4 years. The amount of the number of Facebook users after 5 years. During the years or months, minutes, seconds, that depends. We can actually find the percent increase or percent decrease. So the percent increase is defined this way. We have to do a little bit of algebra. Percent increase, you have your new amount minus the initial amount, or you can say that an old amount. It's easier to write it this way at the previous time. Minus the old amount divided by old amount. And what are we going to do? We're going to multiply it by 100%. Why is that? Because I need percent increase. This is your formula. Now let us take a look at one question. What was the percent increase in Facebook membership between May 2007 and June 2007? So May 2007, June 2007, we need to get back to our table. Do we have any information about May 2007, June 2007? Can we drive those information? Can we calculate those? Okay. So you can write since we don't have the number of users in the table, we need to use our formula. What formula? Y hat equals to 0.8 times 1.0 0.9 to the x to calculate what? To calculate the number of users in June and in May. Y hat for June 2007 and Y hat for April 2007. We need these two information to find a percent increase between April to June. So you need to calculate the number of months between February 2004 to June 2007, February 2004 to April 2007. So we need to find our x values. What is our x? What is our x? Then we're going to use our formula to find y hat for those and then use our formula. Okay, take your time. So April 2007, since February 2004 to April 2007, how many months do I have? What is my x? My x is equal to 38. What is my y hat? When x is 38, my y hat is equal to, I'm going to use this nice formula. If I don't have the information in the table, my y hat is equal to 0.8 times 1.09 raised to 38, which is approximately 20 million users. How about this one, the first one? How many months do you have between June 2007 and February, since February 2004? How many months do you have? What is your X value? 40, very good. Then what's the population? What's the number of users? So if your X is 40, what would be your Y hat? This is your goal. You want to find your Y hat. Y hat is about very good. 25 million, about 25 million. So here, let me just separate these. Your Y hat is equal to 0.8 times 1.09 to 40, which is equal to about 25 million. Now we're going to use our formula to find the percent increase. How many percent it actually increased? So new amount, this is your new amount because you have June, you get 25 million minus 20 million divided by the old amount, which is 20 million times 100%, which is equal to, what's the percent increase? Almost 9%. What would be your calculation here? 25 minus 20 is 5. 5, here you have 5, divided by 20 times 100%. You can cancel out these two. And here, if you divide these two, you get 2.5 and 25%. 25% increase. That's huge. Now, what if I change this to a new month? Suppose you have May 2007. If you have May 2007, so everything is changing now. Your X is changing, your number of users is changing. So if I change this to May, what do you have? Your old amount is changing, everything's changing. Your percentage is changing. So I had April, now I switch to May. I don't have information about May in my table. So how many months? So we just jumped from April to May. So we get 39 months. So we substitute 39 into the formula for X. And what is the number of users? Approximately 23 million. Thank you. 23 million. Okay, now what's the percent increase? New amount, I know that my new amount was 25 million, so I'm going to keep that. My old amount is 23 divided by 23. So here I get 2 over 23 times 100%, which is approximately roughly, let's say 9%, in the best case scenario, 9%. Okay, so it was 25%. If you change it to April, you got 25%. Now that we are changing it to a new month, we get a different number, different value. That makes sense. That absolutely makes sense. These numbers, the initial values, old values are different from each other. So of course we get different percentages.